Hello, my name is Wan Irfan. Today our group will present about the bridge construction of Sultan Abdul Halim Muazzam Shah as Penang Second Bridge. This is our group members, which is me, Wan Irfan, Radin Azlan, Ismail Rifti, Akila, and Rabita. Now we go to the introduction. A bridge is a significant civil engineering structure that enables the transfer across various physical barriers such as waterways, valleys, or busy highway systems. Bridges play an important role in easing access for community and reducing travel time, which helps improve connectivity and economic activity. One prime example is the Penang Second Bridge in Malaysia, which demonstrates the country's capability in advanced and sustainability bridge engineering. This project highlights Malaysia's progress in building durable, innovative structures that meet modern demand for sustainable and efficiency country.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ismail Rifni bin Manso. So we will move on with the type of bridges. As you can see, there are four type of bridges, which are beam bridge, arch bridge, cable stayed bridge, and suspension bridge. So I will explain all of them one by one. So start with the beam bridge. Beam bridge are considered as the simplest form of bridges, which they consist of horizontal beam supported at both ends. When a load is applied, the beam resists it through bending and its shear force. In this process, the top part of the beam experiences compression while the bottom part is in tension. So the key reason why beam bridge are widely used is because how easy and economical they are to construct. This makes them ideal for short spans such as rural roads and pedestrian walkway. Next is arch bridge. Arch bridge are designed using curved elements that help distribute loads upward and downwards. This structure rely heavily on compression force, making them ideal for materials such as concrete and stone, which perform well under compression. In addition to their strengths, arch bridges are often admired for their visual appeal. Many historic viaducts and crossings are built in this form, showcasing their long-standing architectural beauty. Continue with cable stayed bridge. So cable stayed bridge are structure where the bridge deck is supported by cables that connected directly to the towers. These cables are in tension and they transfer the load to the towers which bear them through compression. Compared to suspension bridge, cable stayed bridge provide greater rigidity, which improves stability and reduce deck movement under loads. Because of their sleek appearance and efficient use of space, they are particularly popular in urban environments where both functionality and visual impacts are important. Lastly is a suspension bridge. Suspension bridges are uniquely designed to cover the longest span. In this structure, the deck is suspended by vertical hangers that connect to large main cables. These main cables stretch across the span and are anchored securely at both ends. So, the key advantage of suspension bridge is their ability to efficiently carry tensile loads. This make them this make them ideal for very wide crossing, such as bays and straits. In addition to their functionality, suspension bridges are known for their striking visual appeal and dramatic sweeping spans. Next, move on to the design consideration for the bridges. Effective bridge design relies on several critical considerations, starting with load requirements. A bridge must support both dead loads, like its own weight, and lift loads such as vehicle, people, wind, and even earthquake. So considering these requirements can ensure the design to withstand these forces safely. Next is the soil condition, which determines the type of foundation required. Width, width or variable soil may need reinforcement or ground improvement techniques to ensure the long-term stability. The third consideration is material selection, which is also play a key role. So choice depend on the environment, cost and expected loads. For example, corrosion-resistant steel or geosynthetic are used for durability and strength. Fourth consideration is the durability. This involves resistance to corrosion, fatigue, and wear, especially in harsh conditions. Monitoring vibration and strain over time is essential for the term safety. Finally, is stability. Stability ensure the bridge retains its shape under all conditions. Techniques like combined pyrite foundation improve both stability and sustainability by using fewer materials and reducing emissions.
Assalamualaikum warahmatullahi wabarakatuh. My name is Raja Azlan and I will continue the presentation by presenting the method of construction. Let's start with the beam bridge. There are several ways to build this type of bridge. The cast-in-place technique means concrete is poured directly on site using formwork. Another method is using precast beams, where the beams are made in a factory and brought to the site. We can also use pre-stressed concrete beams, which are strengthened with steel tendons before being installed. Steel girder bridge use large steel beams as the main support. More advanced techniques include incremental launching method (ILM), where the bridge is built section by section and pushed forward, and modular or prefabricated construction where parts are built offsite and assembled on-site. For arch bridge, we have methods like the centering technique, where a temporary structure holds the arch until it supports itself. The cantilever techniques build the arch outward from both sides until they meet in the middle. Temporary cable stay methods help support the arch during construction. Arches can also be built directly on site using in-situ concrete or assembled using prefabricated arch sections. Sometimes a cofferdam is used to keep water out when working on foundation in rivers or lakes. Now for cable stay bridge, these are typically built by cantilever construction from pylons, where deck is added pieces by pieces from each tower. Another method is full span prefabrication and lifting, where wall sections are made off-site and lifted into places. Progressive placement with stick cables means building the deck gradually while attaching cables to balance the load. Sometimes forcework or temporary supports are used. The precast segmented method uses ready-made sections, while the diagonal stick cable installation ensures stability as the deck extends. For suspension bridges, we start with tower construction, usually on both sides of a river, and then comes anchorage and main cables installation, which support the entire bridge. After that, the suspended cables and deck are added. This hold the bridge deck, and next we do cable tensioning and adjustment to make sure everything is properly aligned. And finally, we move to the finishing work and commissioning, preparing the bridge for use. Next, we move into the construction process. For the beam bridge, we begin with site preparation followed by foundation construction. Then we build the substructure like columns or piers. And next is the beam placements, where beams are laid on top. After that comes the construction, and finally the superstructure like guardrails and finishings. For arch bridge, it starts similarly with site preparation and foundation work. Then we build the abutment and piers, followed by first work and erection to support the arch. And then the arch construction comes next. After removing the falsework, the deck and superstructure are built. We end with the final finishing, load testing, and handover. Next, the cable stay bridge. The process begins with a site investigation, then foundation construction. After that, the pylons are built, which are the main towers, and then comes temporary supports and anchorage, followed by deck segment erection, and finally stay cable installation, which supports the deck. For the suspension bridge, the construction starts with site preparation and foundation work, then encourage and tower erection. After that, catwalks and main cables are installed, followed by hanging vertical suspenders to hold the deck. Then we do main span closure, joining the segments together. Finally, the deck sections are installed and the bridge is completed with final work and load testing. Next, we move into the material cost. First, we have the beam bridge. It usually uses reinforced or braced concrete beams to support the structure, and the deck is typically made of concrete. Beam bridges are low to moderate in cost, making them very economical and suitable for shorter spans. Next is the arch bridge. This type of bridge can be built using reinforced concrete, precast concrete, or even stone masonry, depending on the design and location. In terms of cost, arch bridge range from moderate to high depending on the span length, site condition, and especially the need for force work, which is temporary support during construction. The third type is the cable stay bridge. This bridge uses steel cables, reinforced concrete or steel pylons, and a composite of concrete deck. The overall cost is considered mid to high, but they are less expensive than suspension bridges, especially when used for medium span lengths. Lastly, we have the suspension bridge, which is the most complex. It relies on high tensile steel cables, reinforced concrete towers, and a steel or composite deck. This type of bridge is extremely expensive due to the tall towers, long spanning cables, and complicated construction techniques required. In summary, each bridge type use different material and construction methods, and their costs vary depending on the design complexity and span requirement.
Assalamualaikum, my name is Akilah. So for this topic, our group chose a Penang Second Bridge for our case study. The official name is Jabatan Sultan Abdul Halim Muazzam Shah, location on Penang, Malaysia. The length of the bridge is 24 km with 16.9 km of water. The date of construction on 1 November 2008. The date of completion on 1 February 2014 and official opening on 1 March 2014. The cost overall is 4.5 billion. The design used is cable stay bridge and box girder bridge and implemented by Jabatan Kedua Sdn Bhd, owned by the Minister of Finance Incorporated and constructed by CHEC Construction Company from China and UEM Builders Berhad from Malaysia.
My name is Rabita. Next, for the parties involved, the client for this project is Government of Malaysia and Jabatan Kedua Sdn Bhd (JKSB). For the main contractor is UEM Builders Berhad, China Harbour Engineering, and other more contractors are involved because this project are divided into the package. For the civil and structural engineer is HSS Integrated. Engineering consultant is Heson Consultant Engineers, and design consultant is Chowi AS Denmark. For lead consultant is MMSB Consult and RB Perunding. For the QS is Perunding NFL, and M&E for this project is Sepakat Setia Perunding SSFP. For the major company used for the construction of bridge is the pylon, the bridge deck, stay cables, expansion joint, bearings, and the piers and caisson under the water. So for the pylon, it is the tall concrete tower that support the bridge cable section and was made from the reinforced concrete for strength and stability. For the cable stay, it is used to support the bridge deck by using cable and connected to the pylon. It will carry the load and weight of the bridge and vehicles. Next, for the bridge deck. Bridge deck where the vehicle travel across the bridge, and it was made from the precast concrete connected using post-tension steel cables. Next, for the expansion joint, it was installed between the segments of the bridge and allowed the bridge to expand and contract when the temperature change. Next, for the pier. Pier are the vertical support or tall columns which under the water and function to support the bridge deck. It was constructed from the reinforced concrete and designed to resist water. For the caisson, it was a giant hollow concrete structure and placed under the water same with the pier, and they form the deep foundation for the bridge piers. Lastly is bearings. Bearings are placed between the bridge deck and the pier. It will allow slight movement caused by the traffic loads, heat, or wind without damage the structure.
Next, there are two types of construction. First, cable stay bridge. The cable stay bridge used high tensile steel cable connected directly from the bridge deck to tall pylon tower. It is ideal for long spans, especially across deep or navigable waters like the second Penang Bridge. The key features is constructed using the balanced cantilever method. The deck is symmetric from the pylon to the both sides. The main span is 475 meters, allowing large ships to pass beneath. Pylons rise 19 to 100 meters above sea level, and the cables are arranged in a fan-shaped pattern, providing aesthetic value and effective load distribution. The advantage is requires fewer piers in water, ideal for shipping lanes, and modular segmental construction speeds up assembly and reduce the marine construction risk. And the design to withstand strong winds, vibration, and earthquake up to magnitude 7.5. Second type is box girder bridge. Box girder bridge use hollow box-shaped beams made of pre-stressed concrete or steel to support the deck. These structures are highly resistant to bending and make them ideal for both straight and curved path. The key features is used for approach spans and shallow waters in the second pinion bridge. The segments are precast off-site and assembled on-site. The post-tensioning method is used to strengthen the beams and supported by reinforced concrete columns spaced 50 to 60 meters apart. The advantage is use a median span of 30 to 70 meters, which is the most cost-effective and highly stable and torsion resistance, even on curve. And it's suitable for repetitive construction and it's fast installation with precast element. The challenges is require high precision joints and alignment, and the risk of cracking during tensioning if not done properly, and needs proper lifting equipment for the large element. Then we go to the construction process. There are four main construction process. First is foundation and piling work, which is to ensure stability on soft seabeds. The bridge used deep bore and driven piles, reaching over 100-meter deeps. In marine areas, steel piles is used to support heavy structural load. Then the pier and column construction. Reinforced concrete columns are built on the pile to support the structure. The pier caps are placed on the top to act as the foundation for the bridge deck segment. Then box girder installation. Precast box girder are made in the factory and delivered by barge to the site, and crane lift and place each segment accurately using the mesh casting method. Then post tensioning method is done to tighten the steel cables inside the segment for extra strength. The last is cable stay span construction. The tall pylons 19 to 100 meters are installed first, and the bridge deck is built evenly on the both sides using the balanced cantilever method. And the steel cables connect the top of the pylon to the deck and supporting the bridge without the middle columns to allowing ships to pass underneath easily.
Next, the problem encountered during the construction of the bridge and the steps taken. The first problem is the interchange ramp at the second Penang Bridge was collapsed. It was on 6 June 2013, where the section connector of the bridge at Batu Mau Interchange, which around 30-meter length, was collapsed. The ramp collapse was from the project package 3A, which cost around RM 152.7 million. The contractor responsible for that package is the Cegah Semulus Berhad and Giga Engineering Construction Berhad. The collapse of the bridge was caused the vehicle to be trapped. The total of 5 victims have been identified, and one of them has been dead, and two of them is the worker from the Myanmar and Indonesia. The steps taken that has been made for this incident. The project was pushed back by 1 month to give away for Dosh to investigate the site. The contractor, which is Cegah Semulus Berhad, was fined around RM 50,000 according to Section 17 of the OSHA, and for the Giga Engineering and Construction Berhad was fined 35 million ringgit Malaysia under Section 50. And in conclusion, the main cause of this incident, which is inadequate drainage system, formwork support failure, and the worker are not registered with the port CIDB. Next is the problem encountered during the construction of the bridge is delay caused by the land acquisition. The reason is there are a change in ownership of the concession company, which they formed a new company called JKSP to handle everything which managed by the Khazanah. It helps the government with big investment projects. This has caused the individuals who own the land to have disagreements on the preparation fee. Other than that, there are also problems from the package 3D where there are issues regarding to the contractor which caused the delay to the project. The steps that can be taken for this problem is make an early plan by identify the suitable contractor that are capable to manage the project. Next, the change of the ownership should be clarified to the public and give a detailed explanation to the landowner to construct the bridge for taking their land.
Now we go to the conclusion. Firstly, bridges enable community connectivity. They are vital transport infrastructure that span barriers and connect communities, making travel safer and more efficient. Secondly, bridges are powerful symbol of human equity and progress. They represent our gratitude, collaboration, and contribution. Lastly, the evolution of bridge engineering has come a long way today. Today, advanced cable stay and suspension bridges push the boundary of design and sustainability. Together, these points show how bridges are more than just physical structure. They are milestone of our engineering capability and our commitment to connect people and place. Moving forward to the recommendation, there are two key strategies we must focus on the advanced bridge engineering sustainability. First, we need to integrate sustainability and green material in our project. By doing so, we can significantly reduce the carbon footprint and minimize environmental impact to ensuring our infrastructure support a greener future. Second, partnership and skills development are crucial. Collaborating with research institutions allow us to stay at the front of innovation, while investing in workforce training ensure that our engineers and workers are equipped with the latest knowledge and expertise to deliver advanced sustainability bridges. Together, these steps strengthen our commitment to responsible development and position us of continued progress in sustainable bridge engineering.